Welcome to the channel. Today we explore one of history's most dramatic engineering failures. On March 23, 2005, a quiet afternoon at the BP Texas City Refinery turned into a scene of unimaginable devastation. A series of explosions ripped through the facility, transforming a center of industrial productivity into a landscape of wreckage, claiming 15 lives and injuring 180 others. The disaster began during the startup of an isomerization unit. A distillation tower was overfilled with hydrocarbons, which then vented into a nearby blowdown drum. The pressure relief valves opened, but the system could not handle the volume. Liquid surged out of the blowdown stack, creating a massive vapor cloud that ignited, causing a catastrophic explosion that leveled nearby trailers. The isomerization unit was designed to increase the octane rating of gasoline. Central to its operation was the raffinate splitter tower, which separated light components from heavy ones. This system relied on a blowdown drum, a vessel intended to capture liquids during pressure relief events. But this drum was undersized for the unit's actual capacity, creating a dangerous bottleneck in the safety architecture. The CSB investigation revealed a culture of normalized risk. Prior to the explosion, the refinery had experienced multiple releases of hydrocarbons and several near-miss incidents involving the same unit. Despite these warning signs, safety systems remained outdated, and the refinery's focus had shifted heavily toward cost-cutting measures, often at the expense of necessary maintenance and safety upgrades. The failure was a result of a startup procedure gone wrong. Operators were unaware the tower was overfilling until the liquid reached the blowdown drum. The drum's vent stack, which lacked a flare system, released the flammable vapor directly into the atmosphere near the ground. A nearby idling truck engine provided the spark that ignited the cloud, triggering a shock wave that destroyed the temporary offices. The blast wave hit the nearby trailers with devastating force. Because the trailers were located too close to the hazardous unit, they provided no protection for the workers inside. 15 people died and 180 were injured, making this the deadliest industrial accident in the United States in over a decade. The site was left in ruins, and the environmental and human toll became a national priority. The U.S. Chemical Safety Board, CSB, identified systemic failures. They concluded that BP had failed to provide adequate training, ignored mechanical integrity concerns, and prioritized production over safety. The investigation highlighted that the decision to use temporary trailers in a high-risk location was a catastrophic error in site planning and safety management. The legacy of the Texas City disaster changed the industry forever. BP was mandated to implement rigorous process safety management systems and relocate all occupied trailers away from hazardous units. The disaster proved that safety cannot be a peripheral concern. It must be the foundation of engineering. Today, it serves as a haunting reminder of the cost of complacency. The 2005 BP Texas City disaster was not an act of chance. It was the inevitable result of systemic neglect. By failing to respect the hazards of pressurized hydrocarbons and ignoring the structural vulnerabilities of the facility, the company invited catastrophe. The lessons learned forced a shift toward rigorous process safety management, proving that in high-stakes engineering, there is no room for shortcuts. We remember the lives lost not just as a tragedy, but as a mandate for safer industrial practices. Thanks for watching. If you enjoyed this, please like and subscribe for more engineering history.